Now I can quit, 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 quit. There we go. Telnet. What is Telnet? If you work in an enterprise or security and Telnet is a bad word because it's insecure, if someone told you that Telnet is incapable of encryption or TLS, that's bullshit. So let's learn a little bit about Telnet, the Teletype Network Protocol. So as we discussed in the last video, the earliest interfaces to computers are done through a teletype interface. And Telnet extends that over a TCP/IP connection, which you may or may not have already known. Very similar to some of the things SSH does these days. The Telnet protocol came about in 1969, and there are signs of this. For starters, by default, it transmits 7-bit ASCII, so if you want to send this symbol or this symbol or this symbol, you gotta use binary mode, which made sense at the time because there was only 7-bit ASCII, and the high bit was used to signify control codes. Telnet has a series of control codes that are used to negotiate options, to control the remote end, and to control duplexing. At the time, network connections were half duplex. One side could send, then the other side could send, kind of like a really shitty speakerphone. An "Are you there" command, which is used to tell if the remote end is still there and just not sending you any data. That way you could find out if you're still connected without having to type something into the remote terminal. So very much as if you were actually at a teletype sending a message, you would send a go-ahead signal at the end of your data, and then the other side would send anything that it needs to send, and then it would send a go-ahead, and then you'd have free reign to send your side, and so on and so forth, and Scooby-Dooby-Dooby. Telnet operates over TCP port 23, and it uses, as I discussed, 7-bit ASCII. On the client end, the data you would send, aside from control messages, would literally just be the keystrokes that are typed at the console. On the server end, the data that comes back at you would be the output from the remote system, what would be displayed on a screen, or in the earliest use cases, the text that would get sent to your local line printer. The actual formatting of the virtual console or the virtual teletype, or VT, were outside the scope of Telnet. Telnet works with several standards. VT52 and VT100 were video terminals that were in use at the time, so these were actual physical hardware terminals with a screen and a keyboard, and out of the box they would use a serial line to connect up with a system that normally would use a teletype, a remote teleprinter. What Microsoft added to the picture were some optimizations that not only sent the specific keystrokes, but also sent the state of the key, whether it was down or up. If you held down a key and it repeated a couple times, that was sent as metadata instead of sending one key at a specific rate. Microsoft also added the ability to send the scan code in addition to the key code, so that the keyboard layout on the remote end could be different and could tell what actual physical key you were pressing on your keyboard. Telnet is defined in a plethora of specifications. The main protocol was initially defined in RFC 206 and then again in RFC 854, and the Telnet specification allows for a negotiation of options. Telnet specifies the will, won't, do, and don't commands, which tell you which options a server or client is going to support, would like you to support, cannot support, and requires you to not use with that specific Telnet session. Some of these options include echo control. In other words, when you press a key, normally your local terminal would display the character that you typed so that you wouldn't have to wait for the server to send that keystroke back to you before you would see it on the screen. Otherwise, you wouldn't really be able to see what you were typing. But in some cases, the remote program, like for example, if you were playing a game, the remote side could control what was actually displayed. It could turn off your local echo. Binary transmission that allows you to send arbitrary binary data, such as the contents of a file, without it being interpreted as ASCII. Suppress go-ahead, which is used almost unilaterally these days to basically make it a full duplex connection. Without that, you would have to send a go-ahead command or a GA command in order for the remote server to actually send anything back. Extensions related to the size of the actual window, the buffer, the screen buffer. Options for authentication so that you might be able to authenticate using some scheme other than just literally being prompted for a login and typing your credentials in over the actual console session. Options for TLS and SASL to add encryption support and pluggable authentication support. So that's right, you actually can use TLS in Telnet. It's not necessarily insecure. Now, does anyone do this? No, not really. SSH has completely superseded Telnet these days, but if someone tells you that Telnet in and of itself is insecure, it's not. It's just the Telnet server administrator probably didn't implement TLS, and even if they did, your client probably doesn't support it, but it is a thing. The number one reason why you probably don't want to use Telnet these days, especially over the internet, is because no one does implement TLS or SASL. And in most cases, if you log into a system, you are providing your username and password right over that line in plain text. And if this connection is going over the internet, well, then there's many points at which that can be intercepted and sniffed and just read. It's very trivial to see what you're typing as you're typing it. But there are plenty of ways to telnet to a system without actually typing your credential over the wire, as you'll see in a second. And the reason why this is especially a problem is because most telnet sessions are specifically controlling a shell on a remote end. They're used for system administration. I mean, you can telnet to a game, you can telnet to a bulletin board system, you could telnet to a system that just presents you a menu of options, but in most cases, telnet, at least for the last 20 years, was used to control a remote terminal, which meant that your credential probably gave you some kind of privileged access on the remote side. So it's usually not something you want people to be able to sniff. So if Telnet has a reputation for being insecure, that's specifically why. The most common and default implementations don't use TLS. They usually don't use SASL. And it's much easier for system administrators and network administrators to block port 23 and make you use SSH, which requires some level of encryption, rather than just sit there and do like a layer 7 analysis to see if the Telnet connection is using these options or not, which is totally possible. But again, no one does this because the protocol's legacy. Telnet's a relatively lightweight protocol, so embedded systems and systems without a main user interface or a physical user interface, for example, printers, very typically would implement Telnet. It was a very easy way, a very common way to give people administrative control over a system on the network without having to run a web server, without having to have a physical LCD screen. For example, almost all HP printers that are network capable, they have a JetDirect chip or card or module in them that for some time, I can't imagine this is the case today, but for quite a long time, they exposed an embedded Telnet server that you could use to configure that embedded network controller. If you needed to configure its IP address or some network settings, you could just Telnet into it, in many cases without any authentication. I mean, keep in mind, when this stuff came out, the network was not so large that there were untrusted people on it. If you had a device on your network and you could telnet to it, you know, security was implied. Very much how it's implied that if I'm in your house and I have physical access to your telephone, I'm authorized to make long-distance calls. Your telephone doesn't have to authenticate every person in your house. Well, back in the day, your house was basically your organization and maybe a couple of organizations you connected to. Before the internet was a widely popular thing that just had an influx of anonymous user access into anything that you put out there, these types of things weren't really considerations. And that's the case with a lot of protocols, honestly. Another use case for Telnet is to make available remotely serial lines. So a lot of devices had serial lines that they were configured through, whether these were mainframes that primarily connected to video terminals or teletypes over serial lines, or whether they were just equipment that exposed functionality over a serial line. It was very cheap and easy to mate a Telnet connection to a serial line so that remote users could Telnet to a specific address and port number to effectively manage that serial line without having to have multiple wires, multiple physical connections all the way back to a single point in order for them to manage it. For example, imagine like a network server room in a university or a business, or like an ISP where there could be dozens or hundreds of devices that have serial line configurations. Well, you wouldn't have like a central administrator with serial lines for hundreds of devices running back to his desk. He would have a terminal that went to some computer, and he could telnet into specific port numbers, and those would open up connections to the various things that were connected to it. Games like NetHack were very popular over Telnet. Play a game. Let's telnet to alt.org, which is a NetHack server. We can watch some games in progress. I can go down to, I guess we'll watch Death on a Stick play their NetHack game. So the colors that you see are part of the ANSI X3.64 standard, which sends control characters for cursor movement, screen control, like clearing the screen, colors, both foreground and background colors, and in some cases bold, reverse, some other control characters. And you can see, I can literally watch this guy play this game. I could play a game too, but I don't feel like registering. I mean, let's see, I can log in. I'm logged in, now I can play, yeah, pick a role, pick all that, start the game, cool, here we go. So now I don't know what I'm doing, I don't have that object. Do I want to eat? Yeah, I want to eat. I'm having a hard time getting all of it down. I'm satiated. I'm finally finished eating, okay, good. Oh, there we go. Oh, shit. Oh, here we go. Oh, you use the numeric keypad. That makes sense. Okay, there we go. So, what is this D? You swap places. Okay, how about I just go through the door? Oh, look, there we go. There's a hallway. Money. I want money. There's 3 gold pieces. How do I pick them up? Do I do P? Oh, I didn't hit that. There's no shopkeeper here. Oh, I'm not trying to pay anything. I want to pick up the fucking money. Oh god damn it. You know what, just go through the fucking door. I don't know how to play this game, so I'm just gonna... Oh, this hallway just ends. Okay, I'm sorry. Okay, but you get the idea. You can play some interesting games over Telnet. Doesn't have to be all about system administration. And you can even watch certain movies over Telnet. For example, if you want to watch Star Wars in ASCII art, you can Telnet to this address and literally watch an ASCII version of the entire Star Wars film in real time. Dun, 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 dun. A long time ago in a galaxy far, far away. Dun, 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 dun. And all it's doing is just sending you this text data at the appropriate time to update your screen. And these days, with the internet being as fast and as reliable as it is, the discrepancy in the timing of the stuff is so minute that it doesn't matter. You could actually paint rudimentary frames of art as long as you can make them with, you know, ASCII characters on the screen. These days, a lot of people use the Telnet client for diagnostic purposes. People like to think that the Telnet client is the same as a raw TCP client. For example, similar to Netcat. And it's not, but it's close enough that you can actually talk to a lot of different protocol servers like IRC, FTP, HTTP, Whois, ident. You can talk to all these protocols just by telnetting to the appropriate TCP port and typing in as if you are the client. So here I'm going to telnet to an IRC server on a specific port number. I'm going to set a nickname. I'm going to set a username. And there you go. I can join a channel. I can join like testing. Now I'm in the channel. I'm the only one there. I can set a topic. Woo! You know, this is pretty straightforward shit. I can quit and it disconnects me. Let's do a web server. I can telnet to google.com port 80, and I can type get/http 1.1, and I can send a host header. There we go. I can send another one. I can say head/http 1.1, host google.com, send more. It's moved permanently. So www.google.com, so I can say get/http://host. Oh, fuck that up. Host. You can't really backspace when you're trying to emulate a web browser. Host Google. Oops. It's going to get upset. It's going to give me a 400 bad request because I don't know how to type. See? Told you. Let's try that again. Oh, fuck. I typed it too many times. Let's do it again. So when you first start it here, it hasn't sent anything and local echo is off, so my local client isn't showing me what I'm actually typing. www.google.com. There we go. That's the main page of google.com over port 80. And then if I want, I can break out of it using control right bracket and close the connection and quit. I can do email. So let's see what mail servers Gmail uses using trusty DNS 8.8.8.8, 8.8.4.4, telnet to it on port 25 and send a message. I'm going to say, hello, Baba Booey. Oh shit, it doesn't like Baba Booey. Let's try that again. Hello, Baba Booey. mx.google.com at your service, and I'd like to send some mail from blah@buoy.com. What do you mean syntax error? Since when is that a syntax fucking error? Mail from blah@blah.com. There we go, that's okay. I want to send mail to testing123@gmail.com. It doesn't like that. Recipient to... These Gmail servers are really fucking anal. I typed a backspace there, testing@gmail.com. There we go. And now I can do, oh, that email account doesn't exist. Okay, let's try that again. Let's do bobvila@gmail.com. There we go. And I can do data. And now I can just type an email out, you know, from blah.com to bobvila@gmail.com. That's not going to work because I put a space. Damn it. We got to do this again. Oh, it sent it. Wow. Oops. I hope I'm not Bob Vila. I would have just gotten a highly malformed email message. Now I can quit. There we go. Now there's a ton of protocols where this doesn't work for a number of reasons. Firstly, when you're at a telnet client and you're typing input, every time you press a key, your client is most likely sending a packet that only contains that one key value. So if I type out hello world, that string doesn't get sent in a single packet. It gets sent one character at a time, depending on how fast I'm typing it and how much of that text is buffered by the time the telnet client gets around to sending the next packet. Now, most protocol servers, FTP, HTTP, whatever, they don't care because they will buffer it on their end. If they didn't, then people connecting over dial-up, really slow connections, or connections with a really short MTU, they might need to send a command that spans across multiple packets. So most servers don't care about that. They'll sit there and wait for you to hit the end of the line or send a CRLF or send a specific terminating character before they will process your input. For example, HTTP will sit there until you send 2 new lines in a row before it actually processes your request. So you can actually sit there and type relatively slowly and then your stuff will go through. The other reason why this may not work is because there's a couple nuances. By default, at least in the specification, when you hit enter, when you send a new line, instead of sending CRLF, it sends CR null, which might be an issue depending on what protocol you're trying to emulate as a human. But as we discussed in our last video, most server implementations don't give a shit. They'll see a CR and they'll assume that that is a new line. And most protocols will just ignore the null. For example, IRC and HTTP, if you send a null in the middle of the request, they don't care. Really depends on the server implementation. Some do care, but many times that's just filtered out. So you can get away with using a Telnet client to talk to these services. Another issue is that depending on what client you're using, the Telnet client may send control codes to the server because the client is assuming that you're talking to a Telnet server. It doesn't know that you're really talking to Apache and you're trying to pretend that you're a web browser. So when it connects, it might send some of these IAC will option, IAC won't option, IAC do echo, IAC will authenticate. It might send these things. Now, depending on what you're talking to and what protocol it is, they may get ignored, or they may just be interpreted as an unknown command, and then you just hit enter and start typing the real shit. So I've stood up my own Telnet server on a local server in my house, and I'm going to go ahead and Telnet to it. And I'm going to do two different things. First, I'm going to log in securely. I'm going to actually type my password at the prompt here, and you can see that now I'm in and I can do whatever, magical system administration tasks I want to do. And it's just like SSH. I'm just at a command prompt on a remote computer. But if I were to open a packet capture from the server or from any of the intermediary points between me and the server and monitor this login. So I have Wireshark running in the background here so you can see exactly what happens. I'm going to telnet to the server, and I'm going to go ahead and log in. And you can see that every time I press a key, it's sending it as a separate packet. If I go to the packet capture here, and I actually look at the telnet data, the first thing it does is it negotiates a bunch of options, but then once it does that, I can actually look at, see, this is the text that the Telnet server gave me back, and here's the login prompt. And then if I go down the packets one by one, I can actually see my credentials. There's me sending the N, there's the server echoing back the N, there's the I, there's the server. So I do this far enough, I can actually see what my password is. So this is why Telnet in most cases is extremely insecure, but here's the other side of that. If I restart the packet capture and I use a secure client and a secure server, so I can actually hit Y, and if you notice, I'm actually logged in now and I didn't even send a credential. And if I actually take a look and see what happened here, one of the first things that the client says is that it does have the authentication option, it does support it, and the server will honor that. That's what the do and the will indicate here. And then, if you look here, it's using NTLM, which is a relatively secure, give or take, mechanism for authenticating on a Windows network without actually sending your password. And there are all kinds of options and extensions to Telnet. So there's Kerberos extensions, there's NTLM extensions. So it is possible to secure a Telnet in a way where the credentials are not going over the wire. If I go through these packets, you will not see my password. Here we go, it's negotiating the terminal type, which is ANSI. You can see here the client tells the server what my window size is so that the server properly knows how to wrap text. You notice that it settles on using NTLM. First it tries authenticating anonymously and the server rejects that. And then the client, if I drag this up here, you can actually see, whoa, here's the actual NTLM challenge, and here's the response packet. And if you look through here, you'll see the domain name, and you'll see the username. So this right here, this DURMS, that's the domain name, and NILL, that's the username. But what you won't see in here is my password. You won't see that because it's not being sent. And this is just some bullshit where it's negotiating the type of terminal. This is the server asking the client to send its terminal type, and then here's the client sending its terminal type, which is ANSI. So now the server knows that the client supports color and other ANSI control characters. And for the most part, aside from the option negotiation, most of the control commands that are defined in the Telnet specification don't really have a meaning these days. The only one that I found that actually does something, like here, if I break out of the session and I do send abort operation, doesn't actually do anything, like I'm just still here at a command prompt. If I send a process interrupt, it doesn't really do anything. But one thing that I can do is I can send are you there? And when I come back, you can see that the Telnet server, the Microsoft Telnet server, says yes, yes I am, which is much shorter than the response it's supposed to send as per the specification. But I think it's still funny. It's like, yes, I'm here, yes. And then as soon as the virtual console ends, the session ends on the remote side, like if I type exit, the Telnet server closes my TCP connection. And it's that simple. And you can see how this was very versatile and useful back in the day, and it still is. As of Windows Server 2016, Microsoft no longer ships the Telnet server with Windows, and as of I think Windows 7, maybe Windows Vista, the Telnet client is disabled by default. So let me show you how to enable that, because you probably want to play with this and you probably are using Windows. You go to appwiz.cpl and that will open your programs and features, or if you're old school you'll call it add remove programs, and you click turn Windows features on or off and you get this dialog box, and you just scroll down until you see Telnet client, and that's it. If you have an older version of Windows, you also have the Telnet server, but again, you probably don't want to run a Telnet server. So there you have it. If you enjoyed this video or you learned something that you didn't know before, subscribe to my channel and ring that bell and tell one of your techie friends about this. If you're an avid subscriber, support me on my Patreon like these awesome people did. And if you like this video, click the little hitchhiker symbol down there. If you want to learn more, there's some links down in the doobly-doo. I put some more information down there. And if you want to be secure, avoid setting up a Telnet server or set it up properly. And don't use NordVPN. More videos coming soon. Until next time, I'm your colorful, cringy coder cat saying peace. Oh, by the way, there's going to be a lot of people that are upset that I'm not using Linux in this video. Fuck you. Don't tell me what operating system to use. And don't tell Fran Blanche what operating system to use, seriously.